Hi guys, this is Fazan and welcome to this session by Great Learning. So before we start, quickly just write a yes or no if you guys are able to hear me properly. Is there any echo or is there any noise that you are hearing? Just quickly write a yes or no. Hi Komal, hi Mayank, hi MD. Just quickly write a yes or no. Hi Anita, hi Kishan. So welcome all to this session. So today, before we start, while we wait for others to join, just quickly write a yes or no so that we can start quickly. Okay. Okay. Cool, man. Cool. So before we start, while we wait for others to join, okay, Great Learning has come up with an initiative, the Great Learning Academy, right? So in that academy, we have 100 plus courses available. Okay, you guys can check. Okay. So now let's get started. So today's session is again the part 2 session that we have already discussed the part 1. Okay, too much noise. Okay, Puneet. Okay, I will look into it. Okay. So we have already seen the competitive programming part 1, right? There is okay a lot of noise. Okay, installing Visual Studio minimized. Okay. Okay. When is it noise, background noise? Okay, it will just go. Just give it some time. So, right. So we have already seen the part 1, right, guys? So obviously I am not designing these courses that they have dependency on the part 1. So part 1 is individual part, right? And this part 2 is an individual part. There is no dependency of this part on that. Okay. So even if you have missed, no worries. So we will complete first. We will complete this, and then we will then after the session is over, just go through it, the part 1. Okay, guys. So let's get started. So today's session is all about tricks that we use and that I use personally to solve many problems. So within 30 to 40 minutes, we are going to see a trick with which we can almost solve maybe 20 to 25 questions. Okay. So just stay put. Okay. Yeah, the link will be shared, Himanshu. Link will be shared after the session is over, or you just subscribe to the channel and then you will get all the links that are all the sessions of all the sessions will be present there. Okay, man. Yeah, man. Okay, cool, guys. So within 30 to 40 minutes, we are going to solve. I'm going to show you a trick. Rest is up to you. So 20 questions will be covered in this session within 40 minutes. Okay. Okay, Amar, it will be just subscribe to the channel and just go into the channel and you will get all the links. Okay, so you can also subscribe to the channel so that you get notified every time when me or one of my colleagues can when they deliver lecture, you can attend them. Okay. Okay, Amar. Okay, Amar. So let's get started. So as we have seen, let's go first. Let's go through the question. Okay, can I watch it again later? Yes, Arshid, you can. So let's see the question. So find the maximum subarray of size k. Okay, this is the question, right? I'm starting where I left previously, but I want to give you some insight regarding this question. Okay, so you have a question, maximum subarray. You have to find the maximum subarray of size k. The size is given to you. That is, k is given to you. It can be 4, it can be 5, it can be 6. Okay, so the k is 3. Now you have to find the subarray which contains 3 elements at most, right? And it has to be only 3 elements, not less than that, not more than that. Okay, so you need to find the subarray which contains the maximum sum, right? If you can see, 513 is the subarray which is having size 3 and what the sum is 9. So anything that you guys can think of the solution for this? Right, guys, quickly just make it. I'm not friendly with any of the programming language. Can I also participate? Yes, Amar, you can easily. We will just talk about tricks and all those things, right? It's easy to implement, and any language, just the basic knowledge of that you can implement it. Okay, so anything that you guys can think of, any approach, right? So we have already seen this approach, right? The sliding window. You see, first the window size will be 2, right? 1. The window size is 1, right? So 2 will be the element and sum will be calculated. Then we will just traverse through. Then we will just loop around it, right? Now the window size is, yes, because we will see what is the difference between this and the Kadanes, right? Because just give it some time. Okay, cool. So now the window size is 2, right? But what is the required size, window size here? 3, we need 3 elements, right? So now the window shifts 2 1 5, right? After the fourth iteration, now what we did, we just removed 2 and we slided our window, right? 1 5 1 is the window now. Okay, yes, Vikas, sliding window, yeah. So now once the window is sliding, now once we traverse again, right? Now we removed 1 and 5 1 3 is the window, right? Yeah, Pawan, yeah. Okay, cool guys. Why not 5 2 3? Okay, we are talking about sub array, right? Pravat, we are talking about sub array. So sub array has to be contiguous. Okay, Ashish, did you get the answer? The sub array has to be contiguous. You can't just pick elements here and there. It has to be. If you're picking 5, then you have to pick 1 and 3, right? So it can't be that you're picking the first index element, then the last index element, then the 5. Okay, it has to be contiguous. What do you mean by contiguous? So if you have picked 1 5 1, so this is a contiguous subarray, right? 5 1 3, it's a contiguous subarray. You can't pick 2 the first index and 5 at the second index and 2 at the last index. So that's not a subarray. Okay, cool. Now 5 1 3, we slided it again, we got 1 3 2. So every time you can see the max. First of all, we have only one element, then we traverse, then we 2 elements, then we got 3 elements. Then after that, we are sliding our window, right? We are sliding our elements and removing the previous one, right guys? So you can see how sliding window will work. But we must know that there must be a size k, right? There has to be that size k, the window size. We need to have that k, right? So now let's quickly see the implementation of this. So obviously we are traversing only once through the array. So what will be the time complexity? Big O of n. Every element. What is the time complexity? If you talk about time complexity in a naive way, it means that number of what do you mean? Let me make it simple for you guys. Number of operations that you perform or number of unit operations, right? So every time we are traversing this array once, right? And we are not using any. We cannot start directly with the window size. Yes, that is also an approach. Yes, you can do it, but that will make your code look a bit messy, right? So it can do it. It's not that you cannot use it. Yes, you will first pick the 3 elements and put it in the sliding window. You will get the sum of those 3 elements, and then after that you will just traverse from the third index, right? Otoko, Itiko, okay, whatever the name you have written. Okay, so you just do that. Okay, now let's talk about when we traverse one by one. Okay, so we started with the sum and the maximum sum. Every time we calculate that max sum, we will just compare it with that. Okay, now the window the starting index, so that we can just remove the previous element. As you can see, the iterator that I have used is window end. It starts from 0. It's less than array length, right? So after that I just increase the window end pointer, that is iterator. Now every time sum is calculated, I just yes, true, yeah. So every time the elements are every time I am incrementing the elements, right? So we see we have 1. Let me go back to this. We just iterated 2. We put it in the sum. So 2 is the sum, right? After that, what will be the sum? Just a minute. Yeah. After that, what will be the sum? 2 plus 1, 3. Right? Again, you see the if condition that I have used. Is this greater than the window size? No, right? Why I am using k minus 1? Because indexing starts from 0. We know that, right? Array indexing starts from 0. So that's why we are checking. If it doesn't go, to say more than that window size, then what? Unless and until we don't have that window, we will just keep incrementing. So that's why 2, 1 and 3, 2, 1 and 5. Once we incremented these things, right? What we got the sum? We got the sum of 8, right? Now, when we are at what? The third index element, right? Fourth element, right? So after that we see that the window size has increased, right guys? So now we will just the window start pointer, which is currently at 0, we will just subtract that from the window, and I will also check if while doing so I will also check the current sum and the previous sum, right? So that I can get the maximum, right guys? So after that we will just follow along, and all those elements will be removed as we saw in this diagram, right? Is there any confusion in this question? Right? It's simple guys. But where did you declare k? Okay, So k is the input given, right? It's a function. It's not a full program, Amardeep. It's just a function. We got the argument k from the main function, okay? And you mentioned k minus 1. Exactly, because indexing starts from 0, right, Amar? So indexing starts from 0. So if the window size is 3, so 0, 1 and 2, right? It will be covered in this. So 2, I am saying not greater than or equal to 2, okay? So 0 will be covered, 1 will be covered and 2 will be covered. After that, the things will be removed from this, okay? Cool? Okay. So any confusion? Do you have any confusion, guys? So that we can move to the Kadane's algorithm. I want to show you the, show you the difference between this sliding window and the Kadane's algorithm. Okay. Now you see, we solved this. So for sure, it will be declared somewhere else. Okay. Yeah. So now the sliding window is done, right? But in this sliding window, we always have to keep one thing in mind, that we need the window, right, guys? Yeah, so we need that window, right? We need the window. It can be 3, it can be 4, it can be 5. What if this window is not given to us? Okay, find the maximum sub array, right? Explain the loop part again. So the loop part is that we are traversing from each element, right, from 0 to the end of the array. Okay, is it compulsory that window size should be 3? No, window size can be anything. I have never written in this code, I have never written that the first element itself is 9. Or if first element itself is 9, that doesn't matter. We are trying to find the maximum. Okay, we are trying to find the maximum sum of this sub array. Okay, now let me go back to this thing, what Supriya told. And is it compulsory that, no? So I haven't written explicitly anywhere 3, right? It is always k, so it depends on k, right? So never I have written in this code that I am explicitly using 3 the window size, and it depends on k, right? So now Supriya, so the loop thing, right? So first all the elements up to 3, all the 3 elements will be included. It doesn't matter. What doesn't matter? Yeah, it doesn't matter. If first element is 9, we are trying to find the maximum sum. It can be anywhere, right? It can be anywhere, right, guys? So now 1, 2, 3 are the first 3 elements, right? So if part will not be executed, right, Supriya? So if part will not be executed once yeah, cool. So now once we get the 4th element, now the window size has got increased. You see the Supriya here, 2, 1 and 5, the third line, right? 2, 1 and 5. So this is the window. Now we got the element is greater than 3, right? And now what we did, we removed this 2, right? The first element. Okay, Supriya, we removed this element, and now what we did, we then slided our window, right, Supriya? So it was removed with the help of one second. It was removed with the help of this window start, which is currently present at 0th index. Okay, and we incremented that window start. Now it's at 1. So then next time when we slide the window, we need to remove the next element, right? Which is currently the first, second element in the array, right? If you can see the second last line of this, right? Now we need to remove this 1 as well, Supriya. So that's why we are using this if condition. Okay, Supriya? How to visualize nested loops. So you're talking about hello, Kriti. So yeah, we do you take sessions in Hindi as well? Sometimes, yeah, sometimes. So now how you visualize the nested? Are you talking about the time complexity, Raghavendra? So just quickly write. So now this window has been slided. But what if? Okay, got it. Cool. I have a couple of friends who want to hear in Hindi. Cool, Amar. We will. I will just talk to my team and see what I can do. Okay. So now if this k is not given to us, so this k is not given to us. Now what will you do? Sliding window is gone. You cannot implement sliding window. Okay, guys. Because for sliding window, you need obviously what? A window size. So it can be 3, it can be 4, it can be anything, right? But now the window size is not given. Now we have to find the maximum sub array, right? Which is present in this array. If you can see the example, -2, 1, 5, 1, 3, -2. So the maximum sub array that you have, okay, you are talking about time complexity. So basically what you will do, for example, you have 2 loops. let me just quickly go with the question of Raghavendra, then we can start with this. Till then, what all other guys can do, you can just think of a solution for this. Okay, so Raghavendra, there are two loops, right? 0. First we will iterate, the outer loop will iterate from 0 to n. What the other things, what the inner loop, what the nested loop, the second loop, what it will do, it will again iterate from 0 to n. So for every individual index, you are traversing, for 0 you are traversing all the n elements, for 1 you are traversing all the n elements. So this is an n square time complexity. Okay, Vikas Kumar says n. Not for the nested loop, because for earlier question, it was the sliding, he's talking about nested loop. So for nested loop it might differ, but right now what the example I am talking about is what is for, yeah, Arshid, yeah, Kadane's elbow. Why we didn't use first time the Kadane's algorithm? Because window size was given to us. Okay, yeah, the time complexity of this sliding window is okay, the sliding window time complexity was big O of n, because every time we are traversing a single element. Okay, now let's see. Now the window is not given to us. Now we can't use sliding window. Sliding window is gone out of the window. Okay, now we have to find the maximum subarray of this array. Okay, now if you can observe 1 5 1 3 is the maximum sub, because removing the -2 from the first index, which is -2, and the last index, which is -2, we are removing that and we are finding the total sum has to be is the 10. Okay, now, yeah, the earlier Vikas, yeah, the time complexity was 1. Now let's see what is Kadane's algorithm. It is most simple. It's much simpler than that. Okay, if you think about it. Okay, now you know why we didn't use the sliding window. Why didn't we use the Kadane's algorithm in the first question, right? Because there was window size given to us. Okay, now the window size is not given, so we will pick two variables. Okay, one is local and another is global. So global will be the maximum output, right? Your output, that is what will be the output of this array 1 5 1 3. So this global will take care of all the maximum sums. Okay, where can I learn all the array and others? It is given in competitive programming part 1. Okay, after this session, so it is not having any dependency on that part 1, but you will first you will learn this thing, then you can just go back to that, and if you have any confusions, write in the comments of this or that part. Okay, now there are two variables that I am currently dealing with, that is local and global. Okay, now I am going to traverse one by one for each element. If you can see, I have just highlighted them. The text color of all these elements is blue. That means I am traversing only single. Each element is traversed only once. So the time complexity is there itself. Yeah, it's for free. Yeah. So now again I am traversing one by one. Okay. Now the local sum and the global sum. Obviously, right now I am -2. So what will be the local sum? It will be -2. I am using explicitly this int minimum value. The minimum value that any integer variable can have, that is integer.min value. You can use this. So because why I am using this? Because there can be a case where all the elements are negative. At that time you want, for example, you have -2, -3, -4, -1. So -1 is the maximum sum, right? Right, guys? So that's why I'm using it integer.min value. Okay, now I will compare, is this -2 greater than global? Obviously global is negative something, right? 3276 something, right? It's much higher than this -2. So -2 is greater than, I will update what global. Okay, you see the first thing, first iteration, this happens in the first iteration. Okay, now what we will do, okay, takes less time to compile. Yes, C++ takes less time to compile. Okay, now you see, okay, now where are we? Yeah, so -2 is greater than global. Okay, now we will update our global. So global will be -2, and if we have all the elements negative, we don't want to be -2, -3, -4, -5. We don't want that thing. So what I am doing, if the elements are negative, I am just replacing whatever is in the whatever is in the local. I will just initialize it with 0 if the element is negative, if this sum is negative. So right now this -2, this local is having negative values. So what is global? Global is the, I mean to say, there will be a, I mean to say, this global variable is nothing but I am just naming my variables global, which means that which contains the maximum sum every time. Okay, it's not that global, it's just the name, right? It will contain all every time, in each iteration, what is the maximum value. Okay, cool Rahul. Now local will be 0. Now we traversed again. Now what we will see two things. What? Yeah, this is free, and all the parts, I'm going to start a series on this competitive programming, part 1, part 2, part 3. We will just go along the series, and the complexity level will increase each time when I go from 1 to 2, 2 to 3, 3 to 4. Okay, yeah. Now because not the global store, it's just the name of the variable. I just wanted to give you an idea that this global will contain what? The maximum. Yeah, for storing the final answer. Exactly, Arshad. Yeah. So now what I can do, what do you mean by the best? What do you mean by best? Okay, you mean for the best true, still it is best for competitions. Yes, C++ takes less time as compared to Java, but Java is much more simpler to implement. Okay, C++ is also simpler, but most of us are familiar with Java, so that's why I'm also implementing this Java. So that's the reason. But if you are familiar with C++, you can use it. Okay, Rishu. Now what I will do, I will check. Now since global is gone, global is 0, so the next element is 1. I will check, is this 1 greater than global? Obviously this is greater than -2. I will update this 1. Now the third iteration, now I am currently at what? Fifth element. So I will check, is this fifth greater than, or is the sum of the elements previously we have? What is that we have? We will do 1 plus 5, that is 6. Is 6 greater than, or is 5 greater than? That is the current element. What is greater than? 6 is greater than. Done. We will replace the local with 6, and we will check if this 6 is greater than the global. What is the global? 1, right? 6 is greater than 1. We will update our global. Okay. In the now this was the third iteration. Now the fifth iteration, the fourth iteration, right? Now I will check, is 1 greater than, or is the sum of previous, that is 6 plus 1, that is 7. Is 7 greater than what? 6 that we have currently, right? 7 is greater than. Now I will update my local. Okay. After I will update my local, I will again check with the global. Okay. And that's how we do it. Okay. Now just let me show you this code. Maybe this it will help you to visualize better. Okay. Now you see, I have used two variables I talked about, right? Global and what? Local. So global is integer or min value, the minimum value that one can have, and local is 0 currently, right? Now I will loop around it. No. Basically, what the sliding window and this Kadane's algorithm, they are much similar to each other. So that's why I am trying to help you connect the dots. Okay. So basically, one cannot. You saw, if the window is given, we can use window, that sliding window. Now if the window is not given, so the Kadane algorithms is present here. Sound is not clear. Yes, this is easy to than the previous. Yeah. So now I will iterate one by one all the elements. The local variable will contain sum of all the elements, right? So currently, if you talk about this example, this will contain what? Local will contain -2. Now I will check, is -2 less than, or is -2 greater than what? The minimum value? Yes, it is. I will update the global in the first if, right? Now our local variable is -2. If you see, -2, right? If it's less than 0, then what I did, I just I mean to say, I initialize local with 0. Done. Local is 0. We are done with this thing, right? Now that's why. After this thing, right? The first iteration, what was the value that was in local? 0. And what was in the global? -2. This was about the first iteration, right? Done. Now we will be present at the next element, right? Now the next element will be, what is the next element is 1. Now local will contain 1. We will check if 1 is greater than what, or if global is containing -1, -2 is global is -2, right? Yeah, Kriti, this is much easier. Yeah. So global is minus 2. Is it less than local? 1, that is 1. Local contains 1. So yes, so we will update the global and then we will check. Is local less than 0? No, this time local is not 0. What happens if all the elements are negative? Exactly, Arshit, that's why I am using this integer dot min value. Okay, now let's suppose you got the first everyone do you know, don't get confused from what I'm saying, try to understand. Okay, so now is anyone having confusion in this, so that we can go ahead with the Arshit's question? Just quickly write good to go, that's it, so that you can just visualize this code and I will just go to the Arshit's, or if all the sums are negative. Okay, so now let's go with Arshit's question. So he says if all the elements are negative. Okay, for example, let's say minus 2, minus 5, minus 1 and then minus 4. Okay, so now minus 2, local is minus 2, integer dot minimum value, global is also minus 2. Minus 2 is less than 0, local is gone 0. Now minus 1. Minus 1 will be the local. We will compare it with the global. Global is minus 2. Which one is greater? Minus 1. Replace it. Global will contain minus 1. After the second iteration, is minus 1 less than 0? Yes. Local will become again 0. Now minus 5. Is minus 5 greater than minus 1? No. Global will remain minus 1. Now local will again be 0. You see? Arshit got the point? Right? After that we have minus 4. Then why are you what are you guys doing? Okay, now we have minus 4, right? The minus 4 will be compared with what? Minus 1, right? So minus 1 will not get replaced, and what will be the local? Local will again be set to 0, right? What if the elements are same? So it will contain all the array, right? So it will what it will do, for example, 1 1 1 1 1. So okay, what if all the elements are same? For example, you have 1. Okay, local will contain 1, global will contain what? Global will contain also 1 in the first iteration. So local is not less than 0, so local will contain 1. Now we have again 1, so local will become 2, so 2 will be replaced with global, right? So 2 will be replaced with global, and local will is not less than 0 because local contains 2. So now local becomes 3 because again we have 1. So 3 will be replaced with global, right? You see, output is always 0 for negative input. Not always. If the local is 0, only then you just go through it. Okay, it's not complicated. You see, Arshit got the point, right? And who was saying that if all the elements are same, you got the point, right? So if all the elements are Devansh, yeah, cool. Just dry run it with 1 to 3 examples. It will be clear. Okay. Now we saw when to use sliding window and when not to use sliding window. Okay. This is the clarity that I want from these two versions. So that's why I'm using them side by side. Okay. Okay. Cool. Now Kadane is gone. Now let's see. We all know this series, right? This is the famous series, right? Fibonacci series. Yes. Okay. Initially, what will be the value of global? Global is integer or min value, because we don't know, we can't exceed minimum value, right? Integer dot min value, that is the maximum minimum value we can get. Okay, so if we have minus 3, minus 4, minus 5, so that will be replaced. Okay, Arshit, cool. Now we have this Fibonacci series, right? Can anyone just quickly write the recurrence relation for the Fibonacci series? We all know this series, right? There is nothing new to it. Just quickly write the series that the recurrence relation we have for what? Fibonacci series. Quickly guys, I am waiting for you. So just any one of you can write the recurrence relation, right? The recurrence relation means not the base condition, not the logic. No, I don't want that. Self work, not the base condition. I just want the relation upon which we work, right? So the relation is that the previous element and for example, if I talking about the second one, right, it will be sum of the previous two elements, right? So this is the Fibonacci series, right? Yeah, exactly. Do you know? Exactly. Yeah. So Whenever the num is less than, we return num, and sum of the previous two elements is our relation. This is the Fibonacci series. Present sum and the previous two. Cool. Yeah. Right, Arshit. Yeah. Right. Absolutely right. Now let's do one thing. Okay. Let's forget about it. Okay. Let's forget about it. Try to visualize this. We have to find number of binary strings without consecutive ones, right? If you talk about input n equal to 2, right, then this input 2, right, n is 2, so the number of digits we can have is 0 0 0 1 1 0 and 1 1, but 1 1 is not included, okay, because consecutive ones. Okay, yeah Kirti, right? So consecutive ones are present, so we don't have to deal with that thing. Okay, now try to visualize this thing. Okay, when n is 2, the output is 3, because 1 1 is not including, because it contains consecutive ones. Okay, now if n is 3, so what are the elements that we can have is 0 0 0 0 1 0 1 0, okay, and 1 0 0 and 1 0 1 without consecutive ones. Okay, right, Supriya, right? So now this n equal to 2, output is 3. Now n equal to 3, output is 5. What if I told you that this question is asked in many of the big tech companies like maybe DirectEye and all those, Samsung and all those things. And the logic behind this question is simple, that it's again a Fibonacci series. If you see, right, now I'm trying to make you think that these series are very important. Many of the questions solve with this logic. Okay, now if you talk about this thing, right, we will visualize this, the output for the, let me show you the next slide. Okay, now when we had one element, right, for example n is 1, so the two outputs can be either 0 or 1, so output will be 2. When we have n equal to 2, that is two digits, 0 0 0 1 and 1 0, 1 1 will not be included, so output at that time will be 3. Okay, and now if we have three indexes, right, three digits, right, 0 0 0, at that time output is 5. You see, this is the Fibonacci series. So that's why when I told you let's forget about it, I want you to visualize this thing, right? So this is as same as what Fibonacci series. Okay, this has been asked in many of the big tech companies. Okay, and they pay you good amount of salary. Okay, so you see how to connect the dots. The main objective is that, and there are almost 3 to 5 questions which are based on the Fibonacci series concept, and some of them are being asked in Amazon, right? Amazon like companies are asking this question, so you need to think about them. For example, the question that was asked in Amazon was a staircase problem. I will be showing you the staircase problem. Okay, so it will be covered in this session. So right, so you see, based on this simple logic that we have been studying from, I mean to say, whenever we joined the computer science, right, we know the series. But have you ever tried to implement it? Just quickly write yes or no. Okay, now we see this, when we have n equal to 3, at that time the output will be 5, and when we have n equal to 4, the output will be 8. Okay, now if you see the logic, this is the logic. This is again the same logic, right? If you see the same thing that we did in the Fibonacci series, right? Num is less than, then we did this thing, right? Num minus 1 and num minus 2. Okay, if you see the logic for this, right? Okay, yeah, Amardeep, no, you see how to connect the things. Okay, now some of you might be thinking why we are doing plus 2, right? Why we are doing plus 2? Because the first two numbers in the series are not included, because whenever n is equal to 1, oh yeah Kriti, yeah, so whenever n is equal to 1, the output is 2. If you are confused with this thing, okay, if any one of you is confused with this thing, let me show you another approach to the same problem. Okay, what I did, when n is 0, return 0, because we are not able to do anything, right? We don't have n. Let's suppose someone, you can do it less than 0 or equal to 0. Whenever we have numbers like minus 1, right, n is minus 1, though it will be in the question for this problem, it was specified that n is always greater than 1. Okay, greater than or equal to 1. Okay, so now for if someone is not able to get this point, right, why I'm doing function n plus 2 here, then this thing is for them. If someone is able to get both, great. Okay, now let's see. n is equal to 0, return 0, right? N equal to 1, what was the answer? Right, well, answer was 2. It can be either 0 or 1. When n was 2, what was the answer? It can be either 0 0, 0 1 and 1 0, right? I return 3, and after that it's Fibonacci series, n minus 1 plus n minus 2, right guys? Just quickly write a yes or no, and this time also I am just calling the function on n, not n plus 2, okay? If some of you are confused with the earlier approach, okay? Both these approaches will work, okay? So Priya, 3, what is 3? Return 3. You're saying return 3 because n equal to 2. When n was equal to 2, right? What is the output that we have? 3, right? So that's why. Okay, so Priya deleted it. Okay, cool. Okay, now this is done, right? This is the question that was asked in many of the companies. Now there is another problem. This question was asked in Amazon, okay? It's very simple. Again, the logic behind this is same. What? Recursion. Yeah, I mean to say Fibonacci series, okay? So we have to count the number of ways to reach the top. For example, you have stairs. You can either take one step or you can take two steps at a time, okay? Let's suppose n is equal to 1, right? So you can, how many ways you can climb that one stair? Only one way. You can take two jumps or you can take single jump, okay? For one, it is 1, right? Right guys? Just quickly write a yes so that we can make it more interactive, and I feel that you guys are able to understand me. That's why. Okay, yes, cool. Now n is 1. We can climb only one way. There's only one way. We will take one step, right? If n is equal to 2, right? Now n is equal to 2, right guys? So the steps that we can take, what? Either one step, right? Or we can jump to two steps, right? So the output will be, for n equal to 2, what will be the output? 2, right? There is two steps that we can take, 1 and 2. Done. What about 4? We can either take 1 step. That is, this is the first way. Then we can take 1 and then 2. This is the second step, right? The two steps. We can only take one step or two steps, okay? For 3, for the third, again we can take one step and then two steps, then one step, okay? Then also we can do two steps. So the output for 4 is 5. If you again can see, this is a Fibonacci series. Okay guys, just implement it and see it. There are two more questions, right? There is one handshake. You just search applications of Fibonacci series, you will get the questions, and those questions are not asked by local companies like Facebook. Sometimes Facebook Facebook also do a variation of these questions. Amazon has already done. This is the staircase problem. Okay, cool guys. I hope you are enjoying, right? So this is the trick. So with just one logic, what was the logic? Fibonacci series. We are able to solve 5 to 6 problems. Done. Earlier we saw 2 more problems, that is sliding window and that Kadane algorithm. That means we are done with 8 problems. Now let's talk about the main thing that I was trying to say. Okay, now these two series are gone, right? The Fibonacci series is done. You will see the this count the staircase problem. It also follows the same logic, right? That n minus 1 and n minus 2. Again, you can implement if someone is having doubt why I have written what n plus 1 here. Okay. If someone is having confusion that why I have written n plus 1 here, so again he can implement it in this way, in this fashion. Okay, just do. I want you guys to do it. Okay, so that is how you can remember things. Okay, by doing it, by getting confused, you will always remember things. Okay, so you need to get confused. Okay, right? So this is done. Now let's talk about this another series, which is Catalan series. Okay, there are almost 15 questions on this series, and most of them have been asked in direct eye. All those good companies which pay you, I mean to say the salary, they pay you good amount of salary. Okay, so please have more sessions like this, especially for competitive. Yeah, so Priya, we are working on it. Okay, now let's see this series. Okay, the series is similar to what the Fibonacci series. Okay, so 1 1 2 5 is the series. Now how to calculate the series? So basically, if you can see, for 0 and 1 the output is 1. Okay, just like that. What series? Fibonacci series. You don't have to get into the details how the series came. Like Fibonacci series, did we visualize that how this series is coming? What is the mathematical expressions that we are using? We just need to know the recurrence relationship. That's it, and where we can implement it. Okay. Now let's check the series, how we can deduce this. So if you see, for second Catalan number, that is how we can get 2 when we have two numbers. Right now we have 0 Catalan number and 1 Catalan number. How many programs done today? How many programs done today previously? Okay, Abhishek, what you're trying to do? What you're trying to say? Okay, now if you see, we have two numbers, right? 1 1. If you do the cross multiplication of 1 with the you see the arrows, try to figure out what I am doing. So 1 is multiplied with 1 and 1 is multiplied with 1. So we get 1 plus 1, that is 2. Okay, that is the second Catalan number. If we talk about third Catalan number, you see, now we have three elements. What? 1, 1 and 2, 1, 1 and 2. Try to multiply them. Okay, 1 into 2 gives 2. 1 into 1 gives 1. 2 into 2 into 1 gives 2. So when we add 2, 1 and 2, we get 5. This is the fifth Catalan number. Okay guys, so this is the Catalan series. Now what is the recurrence relation? Okay, you don't need to get I mean to say, you don't need to know this thing, but I want you to guys to visualize, so that you can think of what is the next series, what will be the next element. If you guys can quickly write what is the fourth Catalan number, how we will get it, just write this thing. 1 1 2 will be multiplied by what thing? Just quickly guys, I want you guys to give me what fourth Catalan number. Quickly guys, I'm waiting. I won't move. I won't start anything. Okay, I won't be moving forward unless and until you just quickly write what is the fourth Catalan number. Just give me the mathematical equation that I gave you. Right, 2 1 and what? No, Abhishek, this is wrong. This is wrong. Think again. So I want, yeah, just like what Abhishek did, I want you to give me this same thing. 1 1 2 5 into 1 1 2 5. No, Revant, Abhishek wrote 14 plus 5. No, I want you guys to give me fourth Catalan number. Fourth. Abhishek is wrong. Revant is wrong. Think again. 42 plus 14 plus 42. No, this is not. 5 2 2. Yes, Prasanna. Yes, great. Prasanna did it. So anyone having any confusion? 5 2. Devansh did it. Yes, Devansh. Good. Where is Supriya? Supriya, Kriti. Quickly. Amar. The guys who are actively participating in the chat, quickly write this thing. What will be the fourth Catalan number? Shashank, yeah, 14. Mayank, 14. Great. Now you get the point, right? Abhishek, did you know where were you wrong? Did you get the outputs that is shown by others? Yeah, great. Abhishek, did you get it? Revan, do you want me to repeat this thing, how we get it? And Abhishek as well. Where is Supriya? Did you get it? And other guys? Yeah, great, Kriti, great. Yeah, now how we will calculate this thing, okay? Now the Catalan series is calculated in the similar fashion. You don't need to worry about what I am doing here, okay? You just need to remember this thing, okay? Now, if you see, this is the whole program, okay? Now let's go through it, okay? You see, I told you. Raven, did you didn't get it, okay? Let me show you, okay? So, if you have pen and paper in front of you, okay, great Abhishek, great. If you have pen and paper in front of you, just write, sir, is it 14? Yes, it is 14. The fourth Catalan number is 14, okay? Now, if you, I want you guys to, the ones who didn't get it, write 1, 1, 2, and the fifth Catalan, third Catalan number was 5, okay? So, do one thing, write two columns. In first column, write, okay, great, Raven, great. Okay. Yes, sir. This is network problem. My video is stopped sometime. Okay, cool. Arshid, great. So now let's see how we will get it. Okay. Now you don't have to remember this code, but if you can, it's great. I mean to say, you don't have to. You can implement it easily on the other problems. Okay. So now, if you see, I told you, right? If the number is less than or equal to 1, then our Catalan number will be 1. Obviously, you see the first two numbers, and even if it is less than 0, which is not the case, but since we need to cover all the base cases when you're talking about recursion, so that's why what we are doing here. If it's less than or equal to 1, then the answer is 1. Now the result, it will calculate what? The previous one, the sum of those, the multiplication will happen here, okay? This is same. If you try to dry run this code, you will get it, okay? So if you, yeah, Sir, the network problem. Am I not able to see the screen sometimes? Okay, no problem, Supriya. Okay, so now what we have here, okay, what we have, the series. Now what we are doing, we are just multiplying C, this Catalan number. What we are doing here, we are multiplying C. This is C0 and C1, C0 and C1. So when we need to calculate C2, we are just multiplying C0, that is Catalan number 0, with Catalan number 1, plus we are multiplying Catalan number 1 with Catalan number 0. So that's it, what we are doing here. Okay, okay, okay. So this is what we are doing here. Okay, cool guys, right? So this is how we generate this. Now what are the problems that we can do? There are almost 15 problems. Go on to Geek for Geeks, search for the applications of what Catalan series, and similarly just what we did for Fibonacci series, in the same fashion you can do it for this thing as well, right? Let me show you one example. You don't need to know BST, right? I will cover this thing, but I'm showing the application. Okay, now this is a problem that that specifies find the number of binary search trees possible from n nodes, right? N is given to you. For example, if you talk about the first example, that n nodes, there are two nodes, right? Let's suppose 5 and 7. What is the BST? Every time if you are having a root element, the left side will contain less than the root, and the right side will contain greater than root. Okay, if you are not able to get this thing right now, there is no issue. I'm just showing you the application. Okay, you just need to implement what Catalan series. Okay, now if you see, for two nodes, these are the two possible BSTs that we can form. Okay, so now when n is 2, answer is 2. Now what, when n is 3, we can get 5, these 5 binary BSTs. Okay, so for 3, answer is 5. Let me go back to the series. Now for 2 it was 2, for 3 it was 5. Similarly, when n number of nodes are 4, we can get 14 BSTs. Okay, now you get the point. We can implement what? Yes, we will work on that. Okay, I will let the my team know, and we will do something about it. Okay, now you see, when the number of nodes are 4, the number of BSTs that you can form, what, 14. You just have to just copy paste this code, and that's it. That is your answer. Okay, the Catalan series. There are almost I just calculated yesterday. There were 15 problems based on simple this concept, what, Catalan series. Okay, this is all about these two series. Any series you will come across when you are studying or doing anything, I want you guys to just remember that series. Find its recurrence relationship, remember it, keep it in the Excel sheet that I told you guys to create. Okay, so that you can implement while you are trying to solve. You can implement those things. For example, right, sir, where is part 1? So it is in, it is present on the YouTube. You just subscribe to the channel, you will get all the series, or all the live sessions that are happening. Okay, I took it last Saturday. Okay, cool. You got this question right, guys? It is again Catalan series. Okay, just try to dry run this thing. Okay, I told you what is the logic behind it. Try to dry run this. Okay, cool guys, cool. Now this is all about what, Catalan series. Now let's think about this other problem. I want you guys to think, because questions are unlimited. Okay, now based on this simple Catalan series, there are 15 questions, and all have been asked in DirectEye, Samsung, all these good companies. Okay, so you need to, I can't do so many problems, but the problems you need to do the problems, right? I can give you the direction, right? But now if I am doing all the 15 problems based on this Catalan series, that will be waste of time for you and for me as well. Why? Because with that thing you cannot think of on your own. Okay, now I gave you the direction, you just need to follow. Now after this session is over, just go through those examples and see what are the beautiful things you can do with this Catalan series. Okay, you don't need to know the BSTs and all those things. Okay, right? So now let's see this problem. Okay, now you need to find the sum of all the possible subsets of a set. Okay, this is a set given to you, 1 2 3. What are the possible subsets? 1 2 3, 1 2, 1 3, 2 3, and 1 2 3, right? These are the possible subsets. Okay, Ashit. So sir, what is n in cat? What is n in cat? So n is the, okay, yeah. So it is num. There's a misprint. It is num. Okay. Again, the loop is in the loop also. It is num. Okay. Thank you. Thank you, Vikas. Okay. Yeah, it is num. You just need to change this n wherever I have written n. It is the number that is num. Okay. Okay, Vikas. Thanks a lot. So now let's see the sum of the possible subsets of a set. Now, one thing is you just go. I mean to say, go in the question and start finding the subsets, right? But that's not the approach. Okay. Thank you, Vikas. Yeah. Now that's not the approach. I don't want you guys to just go rush into the problem. Okay, that's not the approach that I want you guys to do. So the one approach is that you within so it takes 2 raised power n time to calculate all the subsets in a set. Okay, but this problem can be solved, I mean to say, in n time, right? The time complexity for this problem is n. Try to visualize one thing. If you see the subsets, what do you see? You see that there are, the 1 is repeated 4 times, right? The 2 is repeated 4 times and 3 is repeated 4 times. Exactly, Arshil. Now, if you see, 1 is repeated 4 times, 2 is repeated 4 times, 3 is repeated 4 times, okay? Now if number of elements are 4, that is 1, 2, 3, 4. Again, 1 will be repeated 8 times, 2 will be repeated 8 times, and 3 will be repeated 8 times. 4 will be repeated 8 times. Then if you come up with the I mean to say the formula that Arshit just gave, right? You just need to multiply a of I, that is the element, into 2 raised power n minus 1. That's it. You will get the sum of all the subsets. Okay? Just, you don't need to go rush into the problem. Just give 2-3 minutes extra. Maybe if you're giving 5 minutes to think about the problem, try to see the number of cases. How I came up with this Catalan series problem? Because I tried to visualize what? The number of inputs, right? I gave I took 2 nodes and found that there are 2 elements that two trees that I can form, right? BSTs. 3. Similarly, what I did for this problem, I calculated for 1, 2. I calculated for two numbers. I calculated for 3. I calculated it for 4. So now that I found that it is following this pattern, okay? Great learning number. I asked for this session of. I am asking for the session of PDF for the fake news essential. So Thirendu, you didn't get it, right? You just go into that session. It will be attached to that session. Okay. So now where n is the length of the array. Now when we loop around and try to solve this thing, you will get the sum. Okay. The sum for this 1, 2, 3 array will be what? 24, right? Yeah, it will be some 24, and for this it will be what? 8 plus 16 plus 32, it is 40, 80, right? So the sum for this will be 80, 1, 2, 3, 4, and for the sum of that will be 4. So this is all, right? So this is all about this today, what we are trying to do. Okay, so now I want you guys to go and implement all the series, all the Fibonacci series elements, and all the series that you Catalan series, all the problems on that, and all the problems on Fibonacci series. I want you guys to implement Kadane's. I want you guys to implement that sliding window, and I want you guys to just never rush into the problem. Just try to visualize the number of things that are happening. Okay, for check the check for the test cases. Okay, when you try to do when there are 2 elements, when there are 3 elements, when there are 4 elements, try to think of this so that you don't waste your time, right? As in, if you do it as a normal, in the normal approach, it will take 2 raised power n time, but using this approach, just visualizing it takes n time. Okay, so this is all about today's session. Okay guys, thank you so much. We will come up with next time we will come up with more complex topics, like how we implement stacks in arrays, queues, and all those things. BST will be covered, DP will be covered. Okay, right? All those things. Tries we will do a session on tries as well. Okay, thank you so much guys. If you guys have any confusion or anything that you want from me to repeat or anything, so the slide deck will be shared, everything will be in that. Okay, thank you so much guys. Thank you Vikas, thank you Supriya. When you are going to start graphs, Graphs will take time because that is not something beginners will understand. Okay, do you know? So the next session is on the next Friday, next Saturday, same time. Okay, we'll cover more things. Okay, thank you all. Thank you so much.
Por eso, de nuevo, activo en Instagram y WhatsApp.